For this belt work, we should probably notice right off the bat here that there is no equal sign. So there is no need for principles of equality on this. Now, even with that though, we see first off, hopefully, that there is no equal sign, but then we should see these parentheses right here, which means we need to do some distribution, and it's not just 8 that we're distributing, it's -8. So that'd be -8 groups of 3 H's, which would be -24 H's. And then also -8 groups of -4, which ends up being +32. So we just write that in as +32 right there. The rest of this we can just take and drop. There we go. So again, we're not expecting to use principles of equality. All I'm doing now is looking for any like terms that I can combine. And so I'm going to need to see that as 1H for me. So 4 H's, okay, I'm going to take 5 H's plus 1 H's minus 24 H's. So that's 5 plus 1 minus 24. Just put that in the calculator, get -18 H's. Okay, so that's all the H terms I have. The only other type of term I have on this are constants, and that'll be my second term, and then it'll be fully simplified. So I have a +7 and also a +32, which when I combine, I get +39 right there. Now, this is the way that I have it. Of course, it would be perfectly fine to just write it as 39 minus 18H. So this has a different order, but it still has the same value. It's just the order has changed. So you'll notice that the signs have not changed. It's still a -18H. Even if you make it the second term, or the +39 is, even in front, it still has a positive sign there. So we'll expect to see some of that kind of stuff on the assignment. And so today we're hoping that we can use distribution and combining like terms, not only to simplify equations, but also to simplify expressions like we saw in the bell work. But then as usual, we'll be making zeros and ones to solve equations. If we're going to make a 0, we'll use addition or subtraction principles of equality. And generally, if we're going to make a 1 for the coefficient, it will be the division principle of equality. And the third one, it's still not new. This is kind of a review of what we did last time. Now we need to be able to write and solve equations involving area and perimeter. Some of those will be expressions though, so you'll need to pay attention to your equal sign or if you have one or not. But take a minute and copy these down, please. So perimeter, we see in this one, it's the distance around an object. So it's like asking how much fence you need for a field, and it doesn't really matter what the shape of the field is, it's just the distance around that object. So you could have a star-shaped field, you could have a circle, which usually they call circumference if you care. But today we're dealing mostly with rectangles and triangles. So all the formulas we saw last time for the area of trapezoids and rhombus, none of that stuff really makes any difference on this particular assignment or lesson. Mostly it's just rectangles and triangles. So for a problem like this one, we have a width of a rectangle that measures that, and then length is the other one. Write the expression that represents the perimeter in centimeters of the rectangle. So this one right here, right off the bat, I see that they're asking for an expression. So I'm not expecting there to be an equal sign. There shouldn't be an equal sign. It's just going to be one expression, and then once we get that expression, we will simplify it. All right. Now for me, this one is a rectangle. And so since it is a rectangle, I'm just going to draw one real quick, and I use the technology, of course, since that's easy. But it says that the width is 5R plus 8S, and then the length is 7R minus 7S. So that's what we're going to be using, and it doesn't matter where you put it on the rectangle, which again I'm using, but not everyone uses a picture like this. So if you don't need a picture, then you can kind of skip what I'm talking about right here. But I'm going to put my 5R plus 8S here on the top. And the unique thing about rectangles is that opposite sides are the same length. So on the bottom, I would also have 5R plus 8S. Okay, so that's what I'm going to call the width. Then we have the length of 7R minus 7S. I'm trying to emphasize that S so that it doesn't look like a 5, but it still may look like one. Which means that, again, its opposite side would be 7R minus 7S. Okay, so this is what we have for my rectangle. And again, this would be the outer edges of the rectangle. So if this was a field, I would be looking to see how much fence I got and some sort of formula. Now, I'm going to start at the top and then work my way around. Some students write this differently, which I'll talk about here in a second. But first, I'm going to take my top side length, which is 5r plus 8s. Okay, now that's the top side. I still need to add, I'm going to go clockwise around this. So the next side length is the 7r minus 7s. And then we see that these repeat. So at this point, some students just multiply these by 2, which you could do, but I'm going to keep going around. I like to see all 4 side lengths. So that's a 5r plus 8s. And then the final side length there on the left, we'll have to add that 7r minus 7s. So it's a little crowded in there, but we can still work with it. Now, in this expression that I've written for the perimeter, and again, there's no equal sign, but I'm seeing 2 different types of terms. I've got R terms and S terms. So my final simplified expression will have an R term and an S term, only 2 terms. Now, you'll also probably notice that it did not tell us to simplify it. If it ever tells us to write the expression, always simplify it. If it wants the equation, plan on solving it, okay? So right here, I've got my 5Rs, 7Rs, 5Rs, and 7Rs. And so, of course, we would go in here and just do 5 plus 7 plus 5 plus 7. And that would give me 24 of my Rs. And then we have the S terms. We got the 8 S's, negative 7 S's, 8 S's, and negative 7 S's. So again, in the calculator, that would just show us 8 minus 7 plus 8 minus 7. Okay, and that will result in positive 2 S's. Now again, you could reorder this and write it as 2S plus 24R. I'm not going to worry about that for this one. I'm just going to call that good. Do keep in mind that on the assignment, you'll fill in this box, and then they'll probably have like centimeters out here because this is a measurement. And so we would need the label for that measurement. But when you're doing it on paper, something like this will work. Some students like to put this in parentheses and then label in centimeters. It doesn't matter, but there should be a label. For this one, I'm going to take a triangle. Let's go and draw that over here. Okay, and then I have 3 side lengths, which I should have. Okay, and so I got this one I'll put in red, 5n plus 3p. The next one, color coding is purple, 9n plus 8q. And then the green one, 6q plus 9p. Now, it doesn't really matter where you put these if you're going to make a drawing, which I've done. But I'm going to start on the right with my red side length because I'm just going to go in order. It's 5n plus 3p there, that side length. And then I'll work my way clockwise. So the purple side length, 9n plus 8q. And then the green side length, 6p plus, sorry, that's 6q plus 9p. Now I just made that mistake, but caught it, thankfully in time. But if you make little mistakes like that, that's okay. We can learn from them. So now we're going to take all 3 side lengths. Okay, so I'll start with the red one. And we know it's perimeter, right? So we're going to look at all 3 side lengths, 5n plus 3p. That's the red side length. And then the purple one, 9n plus 8q. And then the green one, 6q plus 9p. And since these are all lengths of the triangle, we're just going to add them together. And just like the last problem, this is an expression, so I am not going to make it an equation. I don't need the equal sign on this. But now that I have these, all 3 side lengths, I'm ready to start combining like terms. I'll start with the n terms. So I've got 5 n's and 9 n's. So that would be 5 plus 9, which is 14 n's. And then I also have p terms. So I got 3 p's and then 9 p's over there. Those are all the p's that I see. So how many p's is that? Well, it's 3 plus 9, which would be positive 12 p's. And then our last term will be the q's. Okay, so how many q's do I got? It's 8 plus 6, which would be positive 14 q's. Now I have it in this order, n's, p's, and q's. You could have put the P's, Q's, and then N's. It doesn't matter which order they're in. That's all I'm trying to see there. As long as you get the same answer, that's all that really matters. But this would be our answer. And like I said before, usually you'll fill in the box and then they'll have centimeters right here. Sometimes what they'll do is they'll put this in parentheses, but it means the same thing. Again, they're just trying to separate the centimeters from the other variables, because otherwise, I mean, they look like letters, right? Okay, so the order doesn't matter. That would be the final expression. And again, we don't want the equal sign because it is not an equation that we should solve. We'll expect to see some of the problems on the assignment to have equal signs. Okay, so we're expecting to solve some equations. Remember, a solution is just a value that you can replace a variable with that will make the equal sign a true statement. It has to be true for what we're doing. Then, of course, principles of equality. We'll be using these with purpose, meaning if we use addition or subtraction, we're going to make zeros. And again, just as a quick review, we've seen the need to zero out x terms as well, so expect to zero out some x terms. And then we have multiplication and division principles of equality, which again, we're going to be using with purpose. We don't want to just divide by random values. We want to be making ones with these. And specifically, if we're going to make a one, it should be the coefficient, which is the number being multiplied by the variable or the letter. So again, principles of equality just tells us if you do it to one side, you got to do the other side, which is why usually when I do this, I kind of set it up like this, right? So if you had something right here and then it equals something else, this is how I set that up so that I know if I do something to one side of the equal sign, I got to do the other side. So area is how much surface space is taken up by a shape. It's kind of like asking if you have a field, no matter what the shape is, how much grass you would need to fill in that field or yard. And if you're looking at a room, it'd be like how much carpet you would need in that room, okay? So it's a surface space taken up by a shape. We'll need to remember when we look at these that area will be in square units. So for example, if your measurements are in meters, it'll be in meters squared, which sometimes is shown as square meters, like this. Or if it was like, I don't know, feet, you'd show feet squared, or again, you can write square feet like this. Okay, these two labels, whether it's in unit squared or square units, these are exactly the same, they're just shown in different ways. And the reason that is because you could actually form squares on whatever shape you're looking at and then figure out how many of those unit squares there are to make up the surface of that shape. I feel like I said too much because I kind of think you guys don't care. But in any case, here's our same process for solving equations we've seen. Distribution, if we see parentheses, we'll plan on distributing, which is just multiplication. Then we will look to combine like terms. After the like terms are combined, if it's necessary, then we use principles of equality to make zeros, which is just addition or subtraction principles of equality. We'll do that to isolate the variable so it's on its own side of the equal sign. And so like we've seen in the past couple lessons, it may be necessary to zero out x terms and constants. So you may have to make zeros twice after combining like terms. After that, you should only need one final principle of equality, though sometimes it's two, to make the coefficient of 1. Usually we use division for that, which I think that's all we're going to be using today. Just remember it needs to be a positive one. So here's my first problem. Let's move this over here. Okay, if the area of the rectangle is 54 square feet, find the value of x. Here is the area that they've given us. Now the formula, in case you don't remember, for the area of a rectangle is length, so I'm making that a cursive L, so that it doesn't look like a lowercase l, which would look like a 1. And then I'm going to multiply this by the width, which you can also make cursive, but that's okay. Area of a rectangle is length times width. Now, for the other classes, what I did is I made the L the 9 right there, but I'm going to purposely make my length the 4x minus 8, okay? Now what this tells me then is I take my length, I replace it with that expression, 4x minus 8, and that's okay. The width is 9 feet, so I take my width, I replace it with 9, And then this would equal the area, which we saw here as 54 square feet. So this is the equation that I have to solve. And so we see parentheses in this problem, and so we're expecting distribution. Just most students think that since the 9 is here, it can't be distributed. Distribution is only multiplication, so we can, in fact, distribute the 9 from this side as well. Okay, so that would be 9 groups of 4 x's, which would be 36 x's, and then 9 groups of negative 8, which would be negative 72. So this still equals the 54. I need 2 principles of equality to finish this one off, zeroing out the negative 72 by adding 72 to both sides. So 54 plus 72 is 126. This equals the 36x is dropped. And then we did zero out the negative 72 as planned. Now, the last thing I want here is for the coefficient of x to be a 1. I want this to be 1x equals something. So I'm going to do that by taking the coefficient 36 and dividing it by itself. 36. And in my calculator, because I don't know my multiples of 36, I have 126 divided by 36, and it gives me the decimal 3.5. Which, of course, you know how to change that into a fraction on these calculators, which would be math, enter, enter, and then you'd get 7/2. It's positive. Now, I'm going to use 3.5 because it's easier to plug in here. But when I do, if I were to replace that x right here with 3.5, question mark, I get a true statement because 4 times 3.5 minus 8 times 9 is actually 54. So since that is true, I can now go into my x here and know that it is actually the solution because it made the equal sign a true statement. So triangles, of course, we'll expect to see those. Now for me, I usually like to see the up and down line be the height. And some students are like, well, how do I find the height? There's no dashed line. That's true, but it does give us this right angle mark right there. So for me, again, I would just say that my height on this one is 9. We have the formula here, and so the expectation is not actually that you have to memorize that, but I suppose you may on the end of year test. But for me, I have found a height of 9. I'm going to put this in parentheses. And then the base is 90 degrees with the height. That's going to be this bottom length, which has a variable in it, and that's okay, but there's going to be 7x. So I'm putting these in parentheses just because I'm multiplying all the terms. For this one also, they did tell us the area of the triangle, so I also need to replace the area with the 189 that they gave us. So this will equal, the 1/2 is just part of the problem. It's part of the formula for the area of a triangle. And so what I'm going to do here is I'm going to simplify the right side all with multiplication. And what this means you can do is you can take the numeric terms and move them around with the commutative property of multiplication. I'm going to show this, although you wouldn't necessarily have to. I'm going to do 1/2 times 7 times 9, and then remember, we'll multiply that by x. But I'm going to multiply those 3 into my calculator. So 1/2 times 7 times 9, enter, and I get this decimal value at 31.5. That's how many x's I have. So this is going to equal to 189. Okay, so all I did is, remember, this was a 7x, that's a 9, there's a 1/2. Just multiply those 3 numbers. That's how many x's you will have. One final principle of equality will finish this off just by making this coefficient of x a 1. And then we'll do that by dividing both sides by the coefficient, 31.5. Okay, so in my calculator, I got 189 divided by 31.5, enter, and it tells me the answer is 6. Now for this problem, sometimes students are like, well, it's 6. This one was in units, 6 units. No, x is part of a length. So if you did 7 times 6, which is 42, that would be the length of this side, and which you could then call 42 units, but the 6 does not need a label. Now, with the other class, I did 1/2 times 7 times 9 times 6, and we did in fact get 189. So there we know that if you replace x with 6, you get a true statement. Therefore, x equals 6 is the solution. Last type that we see on the assignment, going to look something like this one. And here we do see the dashed line of this triangle. Okay, so some students may see this as two separate triangles. It's a big triangle, but it's showing the height in between. And yeah, I guess it's 9 inches again. That's okay. So my height here, I'm going to replace with 9. And then we have a height, the base. Again, the base will be a 90-degree angle with the height, and we see that 90-degree angle there. But that's an expression, x plus 1. So I'm going to have to replace my base with x plus 1. Now, the other information they gave us on this one was that the area is 63 square inches. So I'll have to take my area and replace it with 63. Of course, this still equals 1/2 times all that stuff. Okay, now be careful, because at this point some students are like, I got to do double distribution. You don't. You do not have to do double distribution on this one. What I would like to do, since it's all multiplying, is to rearrange the multiplication with the commutative property of multiplication. Do you have to do this? No, you do not. I'm going to take my 1/2, multiply it by 9, and then multiply that by x plus 1. Okay, now this still equals 63. Again, most students wouldn't show this step. They would not show this step, but I got 1/2 times 9, which is 4.5. Now you can put that in the calculator if you need to. Never feel ashamed to put stuff in the calculator. But now I'm ready to distribute. So I'm going to take my 4.5, distribute it into the parentheses. That's 4.5 times the 1x, which would be 4.5x's. And then 4.5 times 1, which is positive 4.5. So this still equals 63 there. And now that I have that, I'm ready for principles of equality, because I don't see any combining like terms necessary. So I'll zero out that plus 4.5 by subtracting 4.5. So that should be 58.5. Now equals, we'll just drop our 4.5x. And the 4.5 constant zeroed out as planned. Last thing we got here is to force the coefficient of x to become a 1x. And we'll do that by dividing both sides by the coefficient of 4.5. So in the calculator, 58.5 divided by 4.5, enter, I get 13. And again, this is not in units. Now here's the thing, is if you go up here, you place 13 in with x, 1/2 times parentheses 13 plus 1 close parentheses times 9. You do get 63. That tells us that we did in fact find the solution. And so we'll just box that in as our solution. That's it. So our objective, we did see some distribution and combining like terms, not just in equations, but expressions. And then of course we need to know when we need to make zeros and ones to solve equations with principles of equality. And that is in applications of area and perimeter.